So in this lesson we are learning about resistance, right? So to make a current flow through a conductor, there must be potential difference across the conductor. And conductors are different. Conductors will offer varying resistance. Let's begin with copper. Copper is the material that allows the flow of electrons through it with the least resistance. So copper is probably the best conductor of electricity. But another material, nickel, it has more resistance. So it resists the passage of electricity more than what copper does. Resistance is measured in ohms, right? So the formula that we use to calculate resistance will be potential difference across the conductor over the current through the conductor. So that will be the potential difference across a conductor over the current that is flowing through the conductor, which is in amps, right? So let us say that the potential difference across a conductor, let's remember that this is in voltage, right? So let us say that we have measured the potential difference across a conductor and it is 6 volts. So the potential difference across the conductor is 6 volts, and the current that is flowing through the conductor is 3 amperes, right? So that is the formula that we use to calculate resistance. So we simply say 3 there 1 and 3 there 2. So our resistance will be 2 ohms. The unit of measurement for resistance is 2 ohms. That is how we calculate resistance, right? Let's go on to look at factors that affect resistance. So the first factor is the length of the conductor, and I will explain on the length of the conductor. The longer the wire, the more the resistance. This is the same thing with like traveling a distance. So the longer the travel that you do, the longer the distance, the more tired you become. So as electrons are flowing through a wire, the longer distance they cover, the more the resistance. This is more like self-explanatory. Now let's look at the cross-section, how the cross-section area affects resistance. So cross-section here, we are talking about the thickness of a wire, right? So let's take for example that we have got a wire that is that thick, and we also have got a second wire that is that thick, right? So that is the cross section. Okay, so if we try to, this wire will be that thick, the one in black, and the one in red is that thick. So matter is made up of particles. And there are the particles there for that metal. Okay, right. So electrons flow in that direction. Let's say electrons flow in that direction. So the thickness of the wire, the thicker the wire, the easier the passage. The passage has got less resistance simply because there is more space for the electrons to negotiate their way through that particular wire, right? And then we also look at the material that the wires are made up from. So materials also play a role. Remember, when we spoke about the particles of an alloy, for example, we said the particles of an alloy, that is how they are. So an alloy is more dense. Just as an example, an alloy is more dense, therefore there is more resistance in an alloy. They are alloys, of course, which offer easier passage to electricity, but most of them, they offer passage with a lot of resistance. And then let's discuss on temperature, how temperature affects resistance. Right. First of all, I want us to remember that the particles that make up solids, they are closely together and they are vibrating on spot, right? But when they gain heat, they also gain at the same time more kinetic energy. So let's say these are the particles of a wire, right? There we are. Right. At a tight, at a low temperature, these particles are tightly together. They are vibrating on spot. But as they gain heat, they start to vibrate more, right? So what it means is that the collisions between the particles are increased as they gain heat, right? So the increased collisions between the neighboring particles, it resists the passage of electricity because number one, the particles, they increase in size because of heat. Number two, the bumping onto each other, that is increased. This causes, if remember, the electrons negotiate their way through. So negotiating of electrons their way through the wire was much easier when the particles of that material were stable. But because they are bumping, because now when they gained heat, they are bumping against each other more, and that reduces, and they also expanded, that reduces the spaces which electrons can negotiate their way through. So temperature on conductors of heat, the higher the temperature, the more the resistance, for the reason that I just explained, right? But for semiconductors, it's the opposite reasons. So factors that affect resistance are number one, length of conductor; number two, the cross-section area, which is the thickness of the material; number three, the properties of the material. What the material is made up of contributes to resistance. Temperature is the fourth one, is the fourth factor that affects resistance.